Hello everyone, welcome to Connection Wednesdays. My name is Jana and I will introduce what will be the content of today's webinar. Connection Wednesdays is a regular training on design and code check of steel connections in StatiCa connection software. As usual, Adam will guide you step by step through one very nice project of our customer. We are both product engineers at StatiCa. So, before we start, I will just mention that you are muted by default and you can communicate with us via questions panel in GoToWebinar application. So feel free to write any question. We will try to answer them during the webinar, or we will write you an email after. So what will you see today? The first project, or the main project, will be the Anchorage of a spherical storage tank made by a company Odin-Detec from Canada, and Adam will tell you more about this project in a while. In the end, we will have a look at one project from our HelpDesk when the user sent us some anchor which did not calculate properly, and he was asking for the reason why is it so. After the webinar, we will try to answer some questions if we have enough time. And now I will pass the word to Adam, who will start by a short introduction of the customer project. So Adam.
Okay, thanks for the word, Jana, and greetings to all of you in today's webinar of Connection Wednesday. So for today, we have a project from a company, Odin-Detec. That's a Canadian multidiscipline consulting engineering office. They focus in civil and structural engineering. And they took a part on this project of a spherical storage tanks for propane, butane propane tanks, and they've been using StatiCa since 2 years now, and use it for many joints connections with great satisfaction. So about this project, as you saw in the picture, they used the StatiCa connection for code check and design of the Anchorage, which was designed as a circular column anchored to a concrete block with some diagonals and stiffeners along it. And this was all designed in a seismic area, so quite complicated project. And so they took advantage of our software, using it there. So let's take a look. How did they do it step by step in StatiCa? I'll take the presenter and show the screen, and I will show you one big new in StatiCa, and that is a new version 9 that's coming out shortly. So let's see how you can do that in the new interface. Well, it's very familiar, very looks alike like the old one, but it's much simpler and easier to work with. So just the basic topology or starting topology. So I will choose the circular column with some stiffeners, and I will choose the American code AISC, steel grade A36, and let's get started. So we get to the work plane or design plane. We've got the column with some stiffeners and concrete block, and I will start modifying the column. So I just right click and change the cross section, and I'll choose the general tube, and this is now for the American code in inches, so imperial units, so don't get confused. So first cross section, quite a big column. And now I add a new member. So I just right click on members. Here I change the cross section or add a new one, and that will be the square hollow section. HSS imperial, and size will be 12 by 12 by 1/2, which is somewhere here. Yep. Okay. And I put it in the right direction and position. So like this. And now I just copied for the other diagonal. Just change the direction here. So that's for the geometry modeling. We can see this is out of plane diagonals, not in the same plane. So we've got already a, let's say, non-standard joint by geometry, and we'll continue with the job. So next thing will be the loads. So let's see, there are some defaults that were added by the template, and I will import the loads for this model from an Excel sheet. So click on Excel import. I have them here. So I just copy and paste the internal forces from a structure model and bring it here. Replace the old ones, and I have the one load case over here. I can check it on the members. Okay, everything in place. And now let's see about the base plate. So I just click on the concrete block, which is part of the base plate operation BP1, and I'll modify its parameters. This is what we've been using for some time, so just change the thickness and the radius. So now it looks a bit better. And here the orientation is perpendicular to the axis of the main member of the column. And I will rotate it by 8 degrees, like this. Now I change the anchor type. I'll take the grade A325 and pick the size 1 inch. Change its length to 24 inches. And I'll put the washers there, the circular type, size of 3 inches and a radius of 27. As the radius of the anchors, and there will be 8 of them. Good. Now for the welds, I change the leg size to 1/2 inch and turn off the flanges because there is no flange on the column. There is just one circular web. And for the foundation block, change its size, 24 by 60, and I will add a shear iron or a shear lock like this. Is now here on the bottom, and I will change its cross section to I section W imperial, and the size will be 8 by 35. Okay, we got it there. And the length will be 18 inches. Okay, so we got it on place. And we got the welds at the default size, which we can of course change here. Let's say 1/4. That will be enough, or maybe 5 by 8. Make it a bit bigger. So we're on the safe side. You can check later on how they do after we check it and calculate. Okay, so that's for the base plate. And now we connect the diagonals by a simple cut. So I add a new operation, cut of member. And here I will pick the member M2, and I will cut it by M1. And I will use the surface cutting method and just modify the welds, and no flanges, just web all around, and the size will be 1.5, and the outside type of the weld. Okay, and I copy this for the member M3, which is now connected as well. And I can continue by modifying the stiffeners. So let's see. I will use the thickness of 5 by 8 and the size 8 by 18, triangular, and position will be 2 degrees all around and 8 of them. So now it looks like this. And I change the weld size, and weld position is okay for both sides. Good. Now I add another rib. So I can maybe just copy this one and modify its parameters. And so this is stays the same. I will add the rib under the diagonals here to stiffen them. So now the size will be 40, and that will be rectangular. Position will be 75 degrees, and angle 0, and number 1. And this is now on the other side. So like this. I'll change the weld size and leave the double fillet weld. Good. Now I copy that for the other one as well, for the other diagonal. So here I just change the rotation angle to -75, and we got it there. And now to connect those plates with the diagonal members, we use new operation, a cut of member. I will pick member B2, and here I switch to plate and select the rib, And now I will switch to surface cutting method, and again turn off the flanges web and change the size of the weld here, and we'll use double fillet welds here. So now we can see the member is cut around the plate. If I switch to transparent mode, it's better visible. There is a cut in the member in the bottom and top flange, or web as it is named. So I copy this operation for the member M1 and rip 2. Oh, sorry, it's not M1, but M3. Okay, got it there. Maybe you noticed that in version 9, we don't have to modify the member lengths. They are modified automatically if we add any operation. They just align to the optimal length by themselves. All right. Now, if I take a look on the, we are basically done with the design, and if I take a look on the design, mainly on the stiffeners along the tube, there are some, let's say, intersection. For example, for this stiffening plate with the member here, if I switch to transparent mode, and this is something we don't want. So let's say how to sort this out. We could use a trick, and the trick will be that we'll divide the rip operation into 2. So for the first one, I will modify the, let's say, bottom part, or the bottom half from this side of view of the stiffeners. So I will change here the position like this and change the number. So now we get the stiffeners just here and not under the members, while they have their own bigger stiffeners already in place. So now I just copy this operation and change here the parameter, 140 for the angle and 3 for the number, and we got it on the other side as well, right in place. So just a small trick how to edit the stiffeners along the member. And now this is completely done, so we can just calculate and check the results. I forgot to set the thickness here, so I just change it here for the plate, because that was wrong. So now we calculate the joint, standard finite element analysis, and the code check. So this is probably going to take a minute. Yep. I have it already calculated here in other window, but you can just wait a second to get the job done. All right. So we got the results all shining green. That means the utilization is above 60 and less than 95% of its capacity. That means these members, the shear iron, as we can see as well. And we get the overall display or the overall analysis results here in the main window. And if we go to check here, we can browse the results that we are already familiar with from the older version 8. So we can display the stress along the joint and its mesh and the trend of deformation as well. That's for the steel members and plates. Let's see the concrete check. That's for the base plate. There is no plastic zone. We display the stress in the concrete. This is the distribution below the base plate. Okay, we can just focus here and click, for example, on the weld of the shear iron to get the detailed results here in the tab. So we can read all the results and open the formulas behind it. It's the American code AISC. So we can browse the numbers here. And of course, that's for all the welds and the anchors as well. And we can also check the shear iron check and formulas. And that's it. And then we go to report, and that's the end of our job. And we can go to have a lunch or just jump to another project. So this is, I think, all from my side. I just leave to finish the report to display, and I give the word back to Jana, who will show you one HelpDesk highlight also connected to anchoring. So thanks for the attention now.
Thank you, Adam. It was really nice example as usual. So let me share my screen now. Okay, like this, we are back in version 8. I hope you enjoyed the new user interface of version 9, because this week we have the release period. So from the next week, you can start to explore the new user interface yourself. Okay, but this example was sent to our help desk, so it's in version 8, and we will stay by the anchors. So basically the task was to add some extra anchors to already existing anchoring block. So first, the user had such anchors, and he wanted to add another ones. So there can be more ways how to do that, and he chose to add another operation, the grid of anchors. But you can see that you have to keep in mind that you will add only anchors, not the anchoring concrete block. So in the menu of the foundation block, the anchors will be given not to new block but to existing block, and then you just select the CB1 block, which means that only the anchors were added, and now the calculation will run. I have the calculated project here. I copied the project so that we have the results quickly. So you can see that in such a way you can play around with the anchoring, and as Adam probably showed in his example, but he didn't point it out, that from version 8.2 we are also able to check the shear irons. I have prepared an example in the new version, in version 9, so it's with the new interface, and you can see that after you calculate the project, we have also the code check for the shear member of the anchors, and it's also evaluated as a standard member, so with all the stresses and strains, etc. And I think there was one question from our attendees about the weld size. So I have opened our resource center. Maybe let's show again where to find it. So if you just go to our webpage, ideastatica.com, in the top ribbon we have tab resources, and after you click on any of them, you will get to our resource center. Please don't be confused when you try this next week, because we will change also the design of the resource center. So it will look different, but all the content will be there. And this issue is solved in our FAQs under weld size of different standards. So in Eurocode, the weld size is defined by the weld throat thickness, while in AISC, or Canadian code, the size is given by the leg size. So this is the difference, and please keep in mind that you have to enter different size if you use different standard. Okay, and so I think that's all, and let's just jump again to our presentation. Thank you very much for your time. After the webinar, there will be a short survey about how you liked it. It will take only half a minute, so please fill it in. The recording will be available from, I guess, tomorrow on our YouTube channel. And if you are interested in trying StatiCa software, please apply for a trial version. So we also gladly invite you for our next Connection Wednesday, which will be in 2 weeks. It will be April 18th, and I'm really looking forward because it will be held by our UK team, and their projects are always very, very interesting. So please sign up for the next webinar. You will receive the invitation. And that's all for today. Thank you very much for your time once again, and see you next time.
Yeah, see you next time. Have a nice day. Bye.
Goodbye.